Objective B, to add or subtract polynomials. If you're adding or subtracting polynomials, you want to use the distributive property if necessary, particularly when you're subtracting, to get rid of any parentheses. Then you combine like terms. That is, terms with the exact same variables raised to the exact same power. You can write out terms horizontally or line up vertically. Let's look at an example. Here I have 4x squared plus 3x minus 5. I'm going to add to that the entire polynomial x squared minus 7x plus 10. First thing you want to do is distribute this plus. That doesn't change anything. So in fact, this will just be 4x squared plus 3x minus 5 plus x squared minus 7x plus 10. Now we want to group everything with the same power, that is the like terms. In this case, what has an x squared? There's a 4x squared as well as an x squared. That's this term and this term. Now let's look at everything with a first degree. That's this term and this term. So I have plus 3x minus 7x. Those are like terms. Then the constants, negative 5 and 10. So that's minus 5 plus 10. Now that we've organized it, we can combine. 4 of something plus 1 of something is 5 of something. So we have 5x squared. Note the exponent didn't change. I'm just adding together these multiplied objects. Now I have 3x minus 7x. If you have 3 something and you subtract 7, you have negative 4 of those somethings. And finally, negative 5 plus 10 is positive 5. So this is our polynomial. In example 2, we're subtracting. And when you're subtracting, you want to make sure, when you're getting rid of these parentheses, to distribute. So the things at the front stay the same. 4a squared minus 7a. And then I distribute this negative. This negative times this negative gives me a positive 6a squared. This negative times this positive 5a becomes a negative 5a. And then this negative times the last one would be positive 7. So you distribute that negative, and it changes the signs of all of these. If there was a number, you'd multiply. Okay, let's identify things with the same power. The highest degree term is 2. So here we have something squared as well as this. That gives us 4a squared plus 6a squared. Then we have negative 7a minus 5a. And finally, the only constant we have is this here, plus 7. I now combine my like terms. 4 of something plus 6 of something is 10 of that something. Negative 7 minus 5 is going to be negative 12a. And then finally that plus 7. Let's add these polynomials. Go ahead and give it a try. You can pause the video until you're done. Okay. So the ones in the front, there's nothing to distribute. And when you distribute a plus, nothing changes. So this is going to be plus 8x squared minus 10x minus 3. I'll combine everything with a x squared. 4 of something plus 8 of something is 12 of that something. 5 of something minus 10 of those things is going to be negative 5 of those somethings. And negative 7 minus 3 is going to be negative 10. How about you try number 4? Pause the video until you're done. All right. The one out in front, there's nothing to distribute. So it's just 7y squared plus 8y plus 2. Then we distribute this negative. Negative times 4y cubed is negative 4y cubed. Negative times this one is we're going to get negative 9y squared. Then negative times this one will give you a positive 5y. Now let's combine like terms. The biggest degree is the cube, this one here. So that one, there's only one of, and so it goes first, negative 4y cubed. Then we have some squares, this one and this one. 7 minus 9 is negative 2 of the y squares. Then 8y and 5y give me 13y. And finally, this 2 is left over, so that's plus 2. If p of x is this and r of x is this, let's find s of x, which is p of x plus r of x. So s of x is p of x plus r of x. P of x is 3x to the 4th minus 2x plus 1. Right? This equals this. And then plus r of x, which is 3x to the 5th minus 5x minus 8. Let's get rid of the parentheses. Note with the plus, nothing changes, so this is just 3x to the 4th minus 2x plus 1 plus 3x to the 5th minus 5x minus 8. Now I'll combine like terms in descending order. The highest degree is this 3x to the 5th, so that'll go first. There's only one 5th degree term. Then 4th degree terms, only one again, so plus 3x to the 4th. Then the next degree that we have is 1st degree. There's one here and one here. Negative 2 something minus 5 of that something is going to be negative 7 of that something. And finally, we have 1 and this negative 8, which would give us a negative 7. So now we know that s of x equals 3x to the 5th plus 3x to the 4th minus 7x minus 7. Now I want to evaluate s of negative 1. So what is s when x is negative 1? It's going to be 3 times negative 1 to the 5th plus 3 times negative 1 to the 4th minus 7 times negative 1 minus 7. Negative 1 times itself 5 times will just be negative 1. If you have an odd number of negatives multiplied together, you're going to negative. So this will be negative 3. Negative 1 times itself 4 times is going to be positive 1. So we're going to have a plus 3 times 1. And then negative 7 times negative 1 is going to be positive 7. Then minus 7. These cancel, and you get 0.